Hi everyone, a very good evening. Finally, the 100th question, the last question. So here we discuss about the Doppler effect. What is the apparent frequency received by an observer? So when you consider Doppler effect, so the very first thing is when there is a relative motion, when there is a relative motion between observer and source along the line joining them, then apparent frequency received by the observer f dash equal to f into v plus or minus v naught by v plus or minus vs, where v is speed of sound and v naught is speed of observer, Vs is speed of source. So this is what the apparent frequency formula f dash equal to f into V plus or minus V naught by V plus or minus Vs. Now here the main thing what you have to understand is with a common sense, like when to take plus or minus in the denominator or numerator. See, as observer approaches source, then or else as source approaches observer, in both the cases apparent frequency should increase. That means we have to choose such that f dash should be more. F dash should be more means denominator should be less, numerator should be more. That means numerator should become plus, denominator should become minus. And when opposite case comes, like when observer is moving away, then V minus V naught will come. When source is moving away from observer, then V plus Vs will come. Because as their moving frequency should decrease, then denominator should be plus, numerator should be minus. This is the general formula for apparent frequency of apparent frequency received by an observer when there is a relative motion. So that as observer moving away from source, then V minus V naught, same. Source moving away from observer means V plus Vs. Now there are different cases will come, just like see, observer is at rest and source can move towards, or observer is at rest, source may move away from the observer, or else source is at rest. Now observer may move towards, or observer may move away from the source, or else observer and source moving towards, or else observer and source moving away from each other, or else observer is following source or source is following observer. Like these different situations will come. So we have to choose according to the situation plus or minus. Now special cases in the sense, like suppose this is the line joining observer and source, and observer is having velocity like this, some v, and source is having some velocity like this. Now let's take, suppose this is u, this is v, then you should know this angle. Then you have to take component v cos alpha, and this will become u cos beta. Then v naught will become u cos beta, and v s will become v cos alpha. Or sometimes they will give, like when observer uh, when source is moving in a circular path, observer is at some far distance. Now, at one point, the source looks like it is moving away, and at another point, the source looks like it is moving towards. So at one point, he will hear the minimum frequency. Here in this case, F minimum, that is F into V by V plus Vs, because source moving away. In this case, F is maximum, that is F into V by V minus Vs. So like that they will ask question, or else sometimes they will give like one vehicle is there and it is approaching a big wall or hill with a speed u. Then frequency of echo they will ask. Then that is apparent frequency received by the driver itself. That will become like the case. Observer and source moving towards each other with the same velocity. So that V plus U by V minus U it will become. Where V is speed of sound, U is the vehicle velocity, or reverse also they will give. The hill is moving or wall is moving with some speed towards a stationary source. In that case also, the frequency of echo received by the source itself. In that case, the situation will become like observer and source both are coming towards each other with the same speed. Now let's see a few questions. An observer experiences a difference of 4% of actual frequency in the sound from the source when it approaches the observer and when it moves away from him. If the speed of air V is 350. First, it is approaching means F1 is F into V by V minus Vs, and another case F2 is F into V by V plus Vs. And there is a difference of 4% between these two frequencies while approaching and while moving away. First he is approaching, some frequency heard. Then it is receding away, he heard some other frequency. What is the difference in those two frequencies? 4%. That means F1 minus F2 by F1 into 100 is 4%. So if you solve this equation, then you will get the answer. So that is how you need to understand and make the equation. So every question depends on those situations, whatever we have taken. Next, if the velocity of observer moving towards a stationary source be equal to half the velocity, so equal to half the velocity of wave, what is the percentage increase in apparent frequency? If the velocity of observer is moving towards a stationary source velocity 0 is half of the velocity of speed, then F dash equal to F into, as source is at rest, observer is moving towards, so V plus V naught by V, and V naught, if you substitute F dash equal to F into V plus V by 2 by V, that will become 3F by 2. Now what is the percentage increase in apparent frequency means? F dash minus F by F into 100. This is the percentage change. So now F dash place you can substitute F value, then you will get the percentage change. Now the next question is, two trains are moving towards each other at speed 144 and 54 relative to the ground towards each other. The first train sounds a whistle of frequency. Find the frequency of whistle as heard by the passenger in the second train. So now first train is source, that is 144 km per hour means 5 by 18. So 18 8s are 144. So 40 meter per second. And velocity of observer, second train, observer is inside the second train. So that is 54 into 5 by 18. So 15 meter per second. Now both are approaching each other. So both are approaching means apparent frequency is V plus as observer approaching. As source approaching, V minus will become. So now you have V naught Vs and frequency is, what is the frequency? 600 Hertz. Now frequency, apparent frequency they are asking. Now here they have not given the speed of sound, so then you can take 330 meter per second or 320 also, sometimes they will mention depending on the given data. Now two tuning forks with natural frequency 340 Hz each move relative to a stationary observer. One fork moves away from the observer while the other moves towards him at the same speed. The observer hears beats of frequency. 3. Find the speed of the forks. See, the original frequency is 340. Now, here person is there. Now, one tuning fork is coming towards, another tuning fork is going away. Now, you will receive two different frequencies. Approaching means F into V by V minus Vs. And receding means F2 means F into V by V plus Vs. And F1 minus F2 difference is equal to number of beats, that is 3. So now we have all the equations. Speed of sound is there, frequency is there, beat frequency is there. So you can calculate, you can substitute and calculate. So here they are connecting the beat question, beat frequency based questions with the Doppler effect. So they can connect beat frequency questions with stationary waves as well as with Doppler effect also. Now one last and final question. A boy riding on his bike is going towards east. So he is going towards east with a speed 42 meter per second. At a certain point, he produces a sound pulse of frequency 1650. So the frequency is 1650 Hertz that travels in air at a speed of, so the speed of sound is 334 meter per second. A second boy stands on the ground 45 degrees south of east. Now, this is downward is south. This is south. This is east. That means, see here, find the frequency of the pulse as received by the second boy. Now, first thing, one boy is, this is south, this is east. Now this is source moving. And one boy is standing in southeast direction. So exactly at 45. Now, so the boy, second boy is standing somewhere here. Now he is observer. Now his velocity is 0. He is at rest. Now is the first boy moving with a speed. Now he will become source because he is making horn. So Vs will become V cos 45 because along the line joining we have to take. Now it is the case, it will become like source is moving towards stationary observer. That means F dash equal to F into V by V minus Vs, where Vs is V cos 45, where V is or else better you take U because here V means speed of sound. So U into, so U value is 42 meter per second, V value is 334 meter per second, and Vs is U cos 45 means 1 by root 2. Now F value is 1650. So if you substitute all the values, then you will get the final answer. So this way they can ask question in any manner, but after simplifying, it will match with any one of those cases, like whatever 8 cases I have discussed here, like see here. Here I have shown all the different 8 cases. Here observer at rest 2 cases, source at rest 2 cases, and observer source approaching, observer source receding 2 cases, 6 cases, observer following source, source following observer 2. So total 8 cases. So every question depends on these 8 cases only. Accordingly, you can solve the numericals. So similar questions I have given as an assignment also. Just try to understand and try to solve them. So thank you all. Thank you so much. So just try to take care of each and everything and try to revise these topics whenever you get time. So that will definitely gonna help you really in getting very good marks in physics, NEET. So thank you all. Thank you so much.